today? What's on TV? Oh, wrong way. America's Next Top Model. No. Baldwin Hills. No. Dance. So you think you can dance? No. What about the SQUARP Show? It's a little fuzzy. It's a little fuzzy.
SQUARP Show, SQUARP Show, it's the SQUARP Show, it's the SQUARP Show, it's SQUARP, 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 SQUARP.
Hey!
Have you ever sat in calculus class and had no idea what you were doing? Was it ever going to be a clueless young lady who is currently failing in trigonometry? If you need help, or if you can help, call 1-800-355-SQUARP.
They are fools.
Good evening, ladies and gentlemen, and welcome to today's episode of the SQUARP Show, where today's topic will be trigonometry. Today's guest, we have a lady by the name of Penelope Jenkins, and Penelope is struggling in trigonometry. So today we're going to help Penelope out. So y'all give a round of applause for my first guest, Penelope. Come on out. Hello, Penelope. How are you doing? Welcome to the show. Have a seat. So, it's my understanding that you're struggling in trigonometry. Is that right?
I don't know what I'm doing. Like, everything I do is wrong. Like, I don't know what to do.
Interesting. So what seems to be the problem?
Unit circle? Anything? Trigonometry?
Well, that's all right, because today we're going to help Miss Penelope Jenkins out. Ain't that right, audience? Yeah. All right. So our first guest here, we have a doctor professor from the University of A&T. Our first guest is Miss Lexi. Sexy Legs? Lexi. How you doing, Miss Lexi?
I'm fine. How are you?
Thank you. Well, Miss Lexi, as you know, Miss Penelope Jenkins here is a student at James B. Dillon High School, and she's struggling in trigonometry. So today you're going to teach her and the rest of our studio audience here the unit circle.
That's right. And I actually have some gifts for our studio audience. I have some copies of the unit circle. Yeah. Okay, so can I get a couple of pass these out? Thank you. How's everybody doing today?
Fine.
Good. Okay, so does anybody in here know anything about the unit circle?
I do. I do.
Okay, what do you know about the unit circle?
It's a circle of life, no.
Right. Okay, anybody know anything else?
No. I don't know.
Danielle, Mr. Sir. What do you know about the unit circle?
It's round.
Okay, that's enough right there. Okay. So as everybody's getting, might need a little help action right there. Okay, now I've left some things for you guys to fill in with me. We're going to go through this together.
Oh, Lord.
Okay, here's a blown up version of the unit circle. Now the unit circle is kind of split up into 4 parts. There's, okay, y'all know what the coordinate plane is like on the right hand upper right hand side is 2 positives. On the lower left hand side is 2 negatives. And you can remember this because they're straight diagonal. They're diagonal from each other. You know what I'm saying? Okay. Then on the upper left-hand side is negative, positive, and the bottom right-hand side is positive, negative, and they're also diagonal from each other. Everybody got that? Okay, I'm feeling that. Now, on the upper right-hand side, when you go around the circle, you start at 2 pi. Yeah, you start at 2 pi.
Oh.
And okay. Let's start. I like it like this. Let's start from the left-hand side, and it goes pi, and then 2 pi. So once you go all the way around, it's 2 pi. Once you go around like that. So I think it's a space for y'all to fill that in on your unit circle.
Somebody write it down.
This left-hand side is pi, or all the odd numbers in pi on the left-hand side. And on the right-hand side is all the even numbers in pi. Okay, now everybody knows the circle is 360 degrees. Okay. I'm feeling that. Okay, so this first, from here to here, if you split 360 into 4, it's 90 degrees. So 90 degrees per little jam.
Oh, Lord.
Okay. Okay. To get, it's 3 different sections in each jam. So it's 30, 60, 90. But it's a 45 between that because it's 3 of them. Everybody, y'all feeling these in while I'm going along? Yes. Okay, y'all feeling it? Yes. I am too. Okay. So then you have, okay, on your right-hand side, sorry about this, you guys, I'm a little confusing. But you have, for the 30 degrees, everybody filled in 30 degrees, it's also known as pi over 6. That's the pi measurement for it. And the coordinates for that is the square root of 3 over 2 and 1/2. And both of those are positive because, as I said before, all of the points in this jam are positive. Okay, then up here you have 45 degrees, and the pi for that is pi over 4. You getting this? Yeah. Okay. And the coordinates for that are the square root of 2 over 2 and the square root of 2 over 2.
It's very interesting.
Okay, then you have 60 degrees, and pi for that is pi over 3. The coordinates of that are 1 over 2 and the square root of 3 over 2. Okay. All these are positive. Now let's move to the second one. You have 120 degrees, because as I said, we're adding 30 degrees to each one. But this one in between, you're adding 15, because 30 divided by 2 is 15, right? Right. Okay, so 120 degrees, the pi for that is 2 pi over 3. And the points for that is negative 1/2 and the square root of 3 over 2. These points are going to be negative positive because this is on the left-hand upper side of the coordinate.
Miss Lexi Sexy, could you explain it to me? Because back in my day, we only know how to add and subtract and multiply, but this crossing negative line thing, what is this in the quads? What is that?
Okay, well, as I said before, on your coordinate plane, in the first quadrant is actually what it's called, both of the points are positive, positive. Because you go over positive to the right and go up positive, up. And then to the left and up is negative positive because you're going over negative to the left and up positive. Okay, so then you keep doing this and you go all the way around and the points stay the same, the signs just change. Everybody feeling that?
Yes.
Okay. So we're going to leave that up there.
All right, thank you, Miss Lexi. Here you go. That? Understand it here, Miss Penelope?
Yes, I get the unit circle.
All right, well, our next guest is she's from somewhere. Somewhere. Winston State? All right, well, bring it on to Satterfield. Come on out here.
Miss what?
Yes.
Okay, today you will be learning about finding exact value. When you're finding the exact value, you use your trig identity. Yeah, the trig identity. When you're trying to find the cosine of your coordinate on the unit circle, it is the x value. And for sine, it is the y value. And secant is the reciprocal of cosine, which is 1 over x. And cosecant is the reciprocal of 1 over y. You getting this, Penelope?
Yeah.
Okay, good. Tangent is y over x, and cotangent is the reciprocal of tangent, which is x over y. You got that? Okay, good. Now, for example, the cos of 3 pi over 4, which is on our unit circle, yes, and the second quadrant. 3 pi over 4 is pair is negative square root of 2 over 2 and square root of 2 over 2. And then from that, since you're finding cosine, you look at those pairs, your ordered pairs, and you see the x value. So in this case, at 3 pi over 4, the x value is negative square root of 2 over 2. You got that now? Yeah. That's great. Okay.
You better.
Cotangent. Another example. Let's get a little bit harder on you. Okay. Cotangent, which is x over y. Yes. 7 pi over 4. Okay. 7 pi over 4. The ordered pair is square root of 2 over 2, negative square root of 2 over 2. And this part here is steps of how you do it. When you have a complex fraction, you have to flip the bottom and multiply by the reciprocal. Good. That's great. That's great.
Free Penelope.
Yes.
You read.
Yeah. Okay, so once you multiply, you get 2 times the square root of 2 over negative 2 times the square root of 2. And since those cancel out, it's the same on the top and the bottom. You get 1 over negative 1, and 1 divided by negative 1 is negative 1. So the cotangent of 7 pi over 4 equals negative 1. Yes, you got it.
Thank you, Miss Emerfield. Great, great, great job.
Get it together.
All right. Our next guest is Miss Tarakanisha Boneshika Shabambu Brown. From the West Indies all the way out, but she's very educated. So we're gonna bring Miss Nisha Brown out. How you doing, Miss Nisha Brown? Thank you. Let us know what you Yeah, out there.
Okay, I'm going to go over how to simplify using identities. And these are the identities she knows. And these are the Pythagorean identities. The easiest way to remember these is to remember the first one and divide by either cosine squared or sine squared. For example, sine squared plus cosine squared equals 1. Divide those by sine squared and you get
Oh, sorry.
And an easy way to verify the equation is to put together the ones that have the same terms as the identity and substitute them. For example, this equation 10 cosine equals sine. Sine over cosine. Sine is the same as that sine, so you can plug that in so it's easy. And cosine over 1 is the same as sine, cosine. They go together and sine over 1 equals sine and sine equals sine. And another example is sine cosecant minus cosine squared equals sine squared. and the sign.
It's a SQUARP show. SQUARP show.
Just keep Diddy on line one, I'm sorry.
Bye-bye.
And you can substitute cosecant for 1 over sine. So then that equals 1. 1 minus cosine squared equals sine squared. And that identity comes from here. We subtract cosine to the other side, so it's 1 minus cosine squared equals sine. So sine squared equals sine squared.
You look better?
I want to teach something. Can I teach something?
You can, sure.
Okay, what do you want to teach? I want to teach.
Lord.
Wow.
With Sokotoa. Sokotoa. Anybody know what Sokotoa is?
Old ho called another whole trick of America.
No. Let's try Sokotoa. Sokotoa is study our homework can always help to obtain achievement. Not some old ho called another whole trick of America. Sokotoa is sine, which is equals to opposite over hypotenuse. Cosine, which is equals adjacent over hypotenuse. And TOA, which is opposite over adjacent. Triangles. Big old triangle. You know what this is?
Triangle.
Yeah, so what is the hypotenuse?
Is that the slant thing, the heel?
Hypotenuse.
Yeah.
And the opposite and adjacent. Yeah.
See, you didn't have to know all that.
Yeah. This is Sokotoa. That's it. I guess that's it. That's all I want to teach is Sokotoa.
Oh. Well, like I said, back in my day, we only had to know basic rules of math, which was to add, subtract, multiply, and divide. But I got a little coaching myself, just a little bit, and I'm going to teach you how to solve trig equations. So what I need everybody in the studio audience to do is get out a sheet of paper for me so we can take down a couple of rules. Alright. Our first rule is using, to solve trigs, you have to use algebraic rules to apply, including factoring, conjugates, and reciprocals, and also LCDs. Alright? Alright, in our second rule for solving trig equations, we have try to simplify, where you have to try to simplify in terms of the same trig function. Alright, our third rule is to find all greater thans that solve your equations. Alright, then we're going to look at the given intervals, like in example 0 and 2 pi, in between those two intervals. We're going to look at those. And then lastly, choose values in the interval or write the general solution if there's no interval. Alright, so in our first example, we have cost of theta equals 1/2. Alright, so we're going to get rid of the cost, and we're going to get theta by itself. And using your unit circle, which Miss Six Lexi taught earlier, you're going to look and find 1/2 on that circle, and it'll give you pi over 3, or either and 5 pi over 3, plus 2 pi k. Now k equals the number of times you go around the unit circle. Alright? That's example 1. Example 2, we have sine of theta equals negative square root of 2 over 2 equals 2 over 2, and theta equals 7 pi over 4 plus 2 pi k. Alright, and you can also find on there that is 3 pi over 4 plus 2 pi over k, and you have to find which one is in those intervals and you cross out whichever one is not in between. When it is greater than or has a coefficient, solve regular, set new greater than or equal to your answer, and solve. Alright? Thank you, Miss Penelope Jenkins. Are you feeling better about this?
Yay!
All right. Thank you, ladies and gentlemen, for tuning in today on the SQUARP Show. Tune in next time when we talk about ladies, men, and downloaded brothers.
Oh, Lord.